representation on the heart. This is obviously not a scale size of a heart, because people are big there. But before I tell you about the structure of the hearts, I'd like to tell you some interesting things about the heart. For example, in women, the heart is located closer to their head than in a male. Therefore, women make better fighter pilots, according to my teacher, who brag about that all the time. Because since their heart is located closer to their head, during higher G pulls when they're in dogfights, they can maintain blood pressure in their brain and not red out or black out or white out.
Which means what? Is it all the same thing, or are those different stages?
It's just get too much blood in the brain, not enough.
Oh, I see what you're saying.
So red out would be too much blood.
Too much, yeah.
Black out would be not enough, and white out, I'm not sure.
Okay.
But it deals with heart. Your heart also is really important because of the size. The average person's heart is about 14 centimeters long, or about 5.5, 6 inches long, and about 9 centimeters wide, which is about 3.5 inches wide. But in certain people, their hearts don't conform to that size. It's smaller, and that gives them problems with their circulatory system because it's not able to pump blood as efficiently. Or in certain athletes, it's larger, which gives them an edge, such as Lance Armstrong. His heart's slightly larger than the average man's heart, which gives him this great endurance because he can ride all those hundreds of miles in those races and still probably be in better shape after the race than most of us because his heart can pump all that blood he needs to the muscles all the way in his legs, and is still able to pump blood to his head. That's another important part of the heart. You can notice the aorta, which is quite large. Even in a to scale heart, the aorta is very large, large enough you can probably fit your finger in it. And so are the superior vena cava and inferior vena cava. Okay. So I'll show you the process which blood flows through the heart. It's complicated when you don't understand it. It sounds like it's a lot, but it's not really that much. It's 14 steps. So the blood starts at the superior vena cava and inferior vena cava, and they enter into the right atrium. In the right atrium, blood is squeezed through a valve right here. This is the tricuspid valve, and it's squeezed into the right ventricle. And in the right ventricle, the blood is squeezed through a valve right here. This is the pulmonary semilunar valve. Pulmonary semilunar valve, and it goes into the pulmonary trunk. From the pulmonary trunk, it goes into the lungs, where it's oxygenated, which is important. That's where the blood gets it releases the carbon dioxide and grabs the oxygen, which is needed for muscular activity, cell metabolism. From the lungs, it gets back into the left atrium through, put this back on here. It gets back from the right lung right here, from the pulmonary vein. That's the right pulmonary vein, and this is the left pulmonary vein. And these correspond to the right and left lung. It enters the left atrium, and from the left atrium, it goes through the bicuspid valve, or more commonly known as the mitral valve, into the left ventricle. In the left ventricle, you see the aortic semilunar valve right there. That opens and it goes into the aorta, and it flows into the aorta, into the systemic system, which is basically, it goes back to all the other spots from head to toe to oxygenate those cells that are starving. So if you can see, there's only 4 chambers in the heart, but it actually takes 14 steps for it to get from right here to right here, which is about like an inch apart. It's pretty cool. If you notice right here at the tricuspid and the mitral valve, the valves are connected by little strands called chordae tendineae, and they attach to papillary muscles. Yes. And in between the 2 ventricles right here, you'll see the intraventricular septum, which is pretty thick because during compression of the blood, you don't want it squishing or leaking, or you imagine the type of pressure in the heart, you don't want it to flex at all. It's really important. And the valves have to be really strong because during compression of the ventricles, you don't want the blood to flow back. That'd be detrimental to your health. And you hear people have valve operations and big valves to replace damaged valves because it's that important that they don't leak or have problems. The other thing about the heart is it's made out of cardiac muscle. It's not skeletal muscle or smooth muscle. It's completely different. Cardiac muscle is only found in the heart. And unlike skeletal muscle, it's involuntary. You can't make your heart beat any faster by will. But you can make your heart beat faster by thinking about certain things. You can be sexually aroused, you can be depressed. It'll cause your heart to beat faster if you're dehydrated, overhydrated, things like that. It'll cause your heart to beat more quickly. And this is it.